Swayam Prabha. Digital India. Educated India.
Welcome to 15th lecture of video course on tribology. Topic of today's lecture is lubricant classification. In previous lecture, we studied hydrodynamic lubrication and figured out that viscosity is one of the important parameter for the lubrication, but it is not necessary for all kind of lubricants. Viscosity is very important for liquid lubricants. There are other kind of lubricants which we are going to explore today. That is why the topic name is a lubricant classification. Very common sense says that lubricant can be classified based on their molecular structure, strength between the molecule attraction, or we say the overall attraction force between the molecules. We know very well in gaseous state, molecules are distant or not very attached to each other. However, in liquid case, attraction force is more, they come closer, or we say the particle density is more. In case of a solid, particle density is maximum compared to liquid and compared to the gases. So, based on this molecular structure, this kind of molecular structure, we can divide lubricant in gaseous lubricant, liquid lubricant and solid lubricant. But in addition to that, we have one more classification, what we call as semi lubricant or semi solid lubricants, where they have a state in between liquid and solid. They have a flowability, but they show initial some resistance. That is why we say lubricant can be classified as a gaseous lubricants, as a liquid lubricants, semi-solid lubricant and solid lubricant. Every lubricant has its own characteristics. They are preferred in different situations. Maybe gaseous lubricant which have a very low viscosity, lot of gap between the molecules that will give very low resistance against the flow. In that case, the coefficient of friction will be very low, but because of their molecular structure, they are not able to sustain much load. That means, they can be used only, or this kind of lubricant can be used for very low load applications. While a solid lubricant, they can stick, they can sustain very huge amount of the load, they will not be getting squeezed out. So, they have more application when the load is very high. So, in extreme cases of the load and extreme cases of speed, we need to choose a proper lubricant. But before that, let us see what is the importance of the lubrication. It has been realized in one way or another way, lubricants are very important. But we have one table, it says that wear control handbook, it has been picked up from the wear control handbook. Reference has been defined or given on this table, and this says that comparison between hydrodynamic lubrication and squeeze film lubrication. We will be exploring what is the squeeze film lubrication in our next module. Elastohydron lubrication, boundary lubrication, solid lubricant and unlubricated. Unlubricated does not mean that it is not lubricated. There is a possibility of the natural oxides on the surface, but we are emphasizing that we are not doing anything intentionally. No lubricant intentionally has been supplied or applied on interface. So, when we compare wear rate between unlubricated case and solid lubricated case, what we get? Almost a difference of 100. If I say wear rate is 100 units for unlubricated case, we may reduce this lubricate wear with the solid lubricant to the 1% of that, the huge difference. Obviously, the component life can be increased by 100 times, by properly choosing solid lubricant. Does not mean that all solid lubricant will be very good at every interface. There is a need of a compatibility between the solid lubricant and metal on which they have been applied, or polymers, or ceramics on at which interface they are being applied. Similarly, when we compare boundary lubrication and elastohydrodynamometric lubrication, what we find, there is a huge difference. Boundary lubrication, if I assume the 100x, the 100 units, we are going to get a much lesser wear rate, maybe say 0.1 x or the 0.1% of the boundary lubricants. But there is a huge difference here also. What we are talking of the boundary lubricant, and we are talking the solid lubricant. They both have same or almost same film thickness at the interface. Solid lubricant, they are very strict, attached properly to the surface. Boundary lubricants, they require a carrier fluid to flow, but detachment and attachment will be a continuous process. While in case of the solid lubricants, many times if once they are detached from the surface, it will be difficult to again attach that. That is why wear rate may be initially moderate or low. If solid lubricant is removed from the surface, wear rate will increase. On average, wear rate with a solid lubricant will be higher compared to the boundary lubricants, because we have learned the physics of these mechanisms. So, we can use solid lubricant as a boundary lubricant, we can use a carrier fluid with a solid lubricant, and that is one of the most commonly used one of the solid lubricant, that is a molybdenum disulfide. It has been mixed with the lubricant, it has been mixed with the greases, so that grease and liquid lubricant, they act as a carrier fluid, and wherever it is required, solid lubricant or lubricant film is required, solid lubricant or molybdenum disulfide is occupied or occupy that space. Now, before starting the lubricant classification, it is important to understand how to define liquid lubricant or solid lubricant or any kind of lubricant. So, question comes how to define lubricant. Many times when we drive a car on the sandy road, we find car is slipping, coefficient of friction is very low. So, that should be advantageous to us. I can say the sand is acting as a lubricant, or sometime even the surface is uneven, we get a more slope because of that, lesser area of contact, lesser friction. We can say that in this case the gravels are also acting as a lubricant, but that is not the case when we talk about the tribology, when we understand the physics and understand the science of lubrication. We say lubricant can be defined based on the properties. We say that lubricant needs to provide low, but constant and controllable friction. It is nothing like sometimes the lubricant is providing 0.1 coefficient of friction, sometimes 0.5, 0.6 uncontrollable coefficient of friction. It should not happen, and it most commonly happen with the sand or gravels. They do not have any control coefficient of friction. Coefficient of friction continuously changes. It is lower than solid road, but uncontrolled. We do not have much control on that coefficient of friction. So, we say that from that angle, gravels or sand cannot be called as a lubricant. In addition to that, we have a requirement, it should not attack the tribal surface. Attack in the sense majorly, maybe at the nominal or very low level is fine, but at the majorly which is visible, that should not happen, or substance which is going to attack the surface severely or which can be easily quantified, then in that case that will not be acting as a lubricant. So, first thing is that it should provide a controllable coefficient of friction. Second thing is that it should not damage the surface, and finally, it should not be again and again provided, or there is a possibility of some lack of the lubricant, any movement temporarily, So, we require stickiness to the surface also. It should not happen momentarily we are unable to supply lubricant and then system fails. In that situation, that lubricant should be having some adhesiveness with the surface. So, lubricant can be defined based on this. It should provide a low coefficient of friction and controllable coefficient of friction. Second, it should not damage the surface, and third, preferably it should attach the surface or attach to the surface. Now, we defined we classify the lubricant as a solid lubricant, semi-solid lubricant, liquid lubricant and gaseous lubricant. All these are the very big groups. We will not be covering everything in detail, but to some extent we will learn the classification. So, remaining of this lecture will be understanding classification of the solid lubricants. So, solid lubricant, they are basically materials which are having solid state, and they show a low coefficient of friction or low shear strength. So, we can say that solid lubricant, any solid material which can be placed between tribopair surfaces and can be sheared more easily under a given load condition than tribo material themselves. That means, third substance being used between the two materials or a tribopair, and it should be easily sheared. Now, if I go back to our original Strybeck curve, we defined there boundary lubrication. It is interesting to note that solid lubrication also can be defined in the similar state. It follows more or less dry lubrication loss, only the magnitude is decreased. You say that coefficient of friction in solid lubricant can be related to shear force and applied load. The Coulomb law can be used for this kind of lubricants, because they are dry, they are not liquefied, they do not have a flow possibilities to major extent, and that is why we can define using the Coulomb's law, or based on even Archer equation we can define the wear rate. Now, you say that boundary films are formed by interaction of the tribose surface with the solid lubricant. In the presence of solid lubricant, and there will be some mechanical rubbing, because of the tribology is defined based on the mechanical rubbing. There is a possibility of a film of solid lubricant getting transferred to the materials in contact. By and large, that is a mechanism where it works. Before starting solid lubricant, we want to explore what are the advantages and disadvantages. When should we recommend a solid lubricants? First point comes, is more effective than fluid lubricant. Fluid may be liquid lubricant, gaseous lubricants, and grease also has flowability. So, I can define the grease also as a fluid. So, all three, gases, liquid and solid. So, liquid, gases and semi-solid. Solid lubricants are better than that, and those lubricants are more effective than those lubricants, particularly the high load conditions. Whenever the load is very high, lubricant will try to get squeezed out from this interface, and if there is a solid lubricant which has a more bonding strength with the surface, will remain in contact. They will be more effective compared to liquid lubricant, compared to gaseous lubricant, compared to semi-solid lubricant also. Second point, second advantage is mentioned over here is a high resistance to deterioration. They do not get deteriorated, they do not get easily oxidized in storage a common space. They have relatively high temperature stability. Unless a vacuum is being created where they degas, they will try to vaporize. In addition to that, there is a third advantage has been mentioned, that it is a highly stable, or the solid lubricants are highly stable even in a high temperature condition, because they have high molecular attraction, their structure is more stable, they can sustain more temperature compared to liquid lubricant, compared to gaseous lubricant, or I can say the gaseous lubricant, because gaseous lubricants have a much more better properties at the high temperature. They have a more molecular randomness, and then they try to give more viscosity. So, the high temperature case gaseous lubricants are preferable, but solid lubricants are stable. They do not change their molecular structure very easily at a moderate temperature. They are stable against the radiation. They have lesser chemical activities. That is why they can be used at the reactive environments. We talk about the nuclear cases, solid lubricant will be preferable. Now, this fourth advantage is really a very big advantage as a main motive to promote solid lubricants. We say solid lubricant permit equipment to be lighter and simpler. Let us take an example of a liquid lubricant. Liquid lubricant need to be pumped. So, they require pump, they require pipelines, they require sealings, they require some rings to tight. Overall system will turn out to be complex. Many number of components are going to be involved, and there is a possibility of the leakage also. So, that is why the last advantage has been mentioned, they have a cleanliness. Solid lubricant can maintain the cleanliness, there will not be leakage of the liquid lubricant. So, they are better than liquid lubricant from that angle, even better than a semi-solid lubricant like greases. They do not require too many equipments once they have been coated on the surface for certain duration. Of course, so their life is not infinity, they get coated on the surface for some stipulated time. It is nothing like that. Once you coat the solid lubricant, apply a solid lubricant, use a solid lubricant block, it will last for the forever, have a finite life. However, in liquid lubricant we can say liquid lubricant without any additives, additive which is not going to get depleted, they can show or give a infinite life, which is also a very hypothetical case. They have a longer life than solid lubricants, but not infinite life. Now, coming to the disadvantages when we should not recommend solid lubricant. That is one of the important thing is that they do not have a self healing properties. Any lubricant which does not have a self healing properties, one has been distorted from the surface, detached from the surface, solid lubricant cannot go back and heal that defect. So, where it will change? There will be transition. That is why we say that in those situations wherever the more precision is required, where the more reliability is required, either we should use a solid lubricant with the carrier fluids, or some mechanism should be there, the some healing device is been utilized with a solid lubricant. This says that a broken solid film tends to shorten the useful life of lubricant. If we have designed a solid lubricant for the 1000 hours, and quite possible it shows only 10 hours, 12 hours, 15 hours. Another major disadvantage about solid lubricant is that their thermal conductivity and heat dissipation capabilities. They work only with the conduction, there is no convection. Radiation is hardly come into the picture. And conduction also, if we do not have any carrier fluid, we do not have any cooling agent nearby or passing through the device, then heat dissipation will be difficult. What if the heat generated will be accumulated on the surface and will necessarily increase the temperature. But if there is a cooling devices available, cooling fluids are available which can cool the surface, then this kind of solid lubricant can be recommended. but if there is no availability of cooling agents or cooling devices, then we should not recommend, reason being that solid lubricant already show high coefficient of friction compared to liquid lubricant coefficient of friction. So, heat generation will be more at the solid lubricant interface compared to liquid interface. And that case, if in addition to that there is no provision to carry away the heat and applied load is very high, relative speed is very high, then we should not recommend a solid lubricant. Last disadvantage has been mentioned over here is that it has a high coefficient of friction and high wear rate. Now, wear rate is one of the subjective thing in this case. We say the wear rate of the solid lubricant itself can be counted as the wear rate, or sometime people say that wear rate of the material which come in interface. Here the coating has been applied or the solid lubricant has been applied, if it wears out, then it is going to give a condition as an unlubricated condition, the wear rate will increase. So, first the wear rate of the solid lubricant and subsequent the wear rate of the metal which are the interface will be high, and of course, the coefficient of friction will be high because they have a high bonding strength with this interface, and they do not show or do not give very low coefficient of friction, low shear strength, because of the solid structure, a solid state, they will have a higher shear strength compared to the liquid interface or a liquid state. I am showing starting a solid lubricant now. We say that one way to apply a solid lubricant or pass a solid lubricant or supply solid lubricant and interface is simply brushing component with a solid lubricant or rubbing component with a solid lubricant. Just to elaborate what I am trying to convey, I am showing two diagrams or two photographs. These photographs, both the photographs are the same eccentric cam, and this eccentric cam has been coated, has been rubbed with molybdenum disulfide powder. Molybdenum disulfide powder is somewhere in lesser than 1 micron size. When we rub it, we will find a really a good shiny surface of the cam. When we operate this cam at the maybe say 60 rpm and the lab experiments, after 3 hours of operation, we find that complete molybdenum disulfide has been removed from the surface. You can see the worn out the surface over here. This worn out surface clearly shows that there is no molybdenum disulfide. It has been molybdenum disulfide has been removed from the surface. So, that is the major disadvantage. We use operation, we apply molybdenum disulfide and been removed. So, easiest way is that you use some sort of carrier fluid with a molybdenum disulfide. Carrier fluid will be a continuous media to supply molybdenum disulfide at the interface, and under high load condition, and relative condition, they will keep depositing this kind of the coating, and surface where we say that coating will be applied and then removed, applied and removed, it will act like a bonded lubricants, and the wear rate, overall wear rate will be lower case. That is why we say the molybdenum disulfide can be mixed with liquid lubricant, can be mixed with the greases, they will show better performance. However, the problem comes to the filtration. If filter is very low rating, obviously that beta rating is very low in that case, and the molybdenum disulfide also will get filtered. That means, in that case we need to choose a proper filter. Now, there are two important requirements which need to be there from solid lubricant. We say that it should be able to support the applied load, it should not tear away. It should not happen that the structure of solid lubricant get distorted. Many times we have this kind of we did a number of experiments, we found the graphite happens to be getting distorted in the structure. Sometimes it is effective, sometimes it is not effective under high load condition. There should not be any significant distortion, that is why that is mentioned over here, deformation or loss in strength. They should not have a creep behavior. Most of the polymers have the creep behavior. If you apply a stress of maybe say 20 or 25 megapascal, they will show a good performance initially, and with the time the performance deteriorates. because of the creep behavior, they start flowing, they will show the different properties. So, as far as possible, they should not lose a strength. If solid lubricants are losing its strength, then we should not use those lubricant for that kind of load. We should use those lubricant at a slightly lower load, or load which can show without creep behavior. And second thing is that we need to choose a coefficient solid lubricant as per the desirable coefficient of friction. Few solid lubricant show the coefficient of friction 0.05, few solid lubricant show the coefficient of friction 0.1, few solid lubricant 0.2, few solid lubricant 0.3. So, depends on the condition, depends on what kind of coefficient of friction is desired. We should use coefficient of friction that way, and similarly we should use the rate of wear which is acceptably low. It should not happen that we are designing component for the very high life and we are choosing solid lubricant. The possibility of the wear, and that will reduce the wear, and this will increase the clearance, and that may reduce the overall service life or operating life of the component. Now, I mentioned one way to give or apply a solid lubricant on the material which are coming into contact, like cam. But there is another way. We use solid lubricant as a bonded coating. That means they have some sort of binding agents. With those binding agent, we try to apply solid lubricant. There are a number of binding agent, but we can classify according to their structure, which is organic binder and inorganic binders. Organic binders generally have a temperature limit. They are particularly resins and which are having sticky behavior. They lose their behavior at the temperature more than 300 degrees centigrade. That is why this kind of coating, as this kind of solid lubricant coating, should be used when the operating temperature, obviously the maximum temperature is lesser than 300 degrees centigrade. Otherwise, the high temperature, they will start liquefying, will start flowing, and the solid lubricant will not stick. That will not remain effective. But if the operating temperature is lesser than 300 centigrade, then we can use resin based binders, and we can apply, or we can stick solid lubricant to the components where they are desired. Similarly, we have inorganic binders. Here the metal composition comes into picture. Sometimes we use ceramics also, or we use a mixture of all. They remain stable at the higher temperature. The temperature can even reach up to 650 degrees centigrade, which is quite huge at the most of the tribo interfaces, and they are effective. This kind of binders are effective at the 650 degrees centigrade. Of course, the research is always on, and people make resin binders which are can be operated at 350 degrees centigrade, 400 degrees centigrade, but still that is a research from research point of view, not from a commercial point of view. What is been mentioned here is the more common, which is available in market. Now, when we have this kind of binder mix pigments, what we say that solid lubricant as a pigment and then a binding agent. So, that can be applied or on the surface by spraying, having some velocity. You impinge at some velocity, which will make an undulated surface and deposit the solid lubricant on the surface. So, another one is that if they have a chemical some potential, in that case the dipping will also help. However, there is also a possibility that we can brush it and mechanically, maybe solid lubricant mix with component is run under mechanical condition, brushing condition for maybe a couple of hours, maybe 3 hours, 5 hours, and all component will get coated. This molybdenum disulfide is also deposited on interface by using this kind of coatings, this kind of methods. We say that spraying is one of the common technique. It can be thermal spray, or it can be used in the velocity guns. Spray is a very commonly used technique, while dipping is less expensive. So, when we do not have extensive number of components. So, we are trying to use initially doing more experiments, we can use a dipping. Only thing is that solid lubricant need to be mixed properly with fluid. Now, few notes, a few conclusions based on what we have mentioned in this can be stated. Say that to apply solid lubricant as a coating form, we require a good surface preparation. Some irregularity on the surface will help us to easy depositing the solid lubricant on the surface. So, that is why most oftenly we use emery paper to rub the surface, make a slightly irregular surface, and then apply solid lubricant on the surface. So, surface preparation is important. Now, utility of the emery paper rubbing can be said in number of ways. One is that giving a slightly rough surface. Another thing is that is removing the contaminations from the surface. We know if there is a contamination on the surface, then adhesiveness between the solid lubricant and the parent material will not be that much, because in contamination generally have a low shear strength, and then that bonding will be reduced. It will remove, or if we rub with emery paper, it is going to remove the contamination to some extent. And of course, if we keep again after rubbing for a number of hours, again the oxide layer will be formed, it will not be effective. So, that means rubbing as well as immediately after that deposition of the solid lubricant will help. Sometime we use temperature coating, like we are talking about the resin based, or we are talking about the binders to be mixed with the pigment. Naturally, cooling or particularly curing is important in those situations. It can be air cured, allow temperature to fall as per the environment, or other one is a controlled one. That is what we call the heat cured coatings. Heat cured coatings means we control, regulated the maybe say the 500 degrees centigrade for some temperature, so for some hours, then 300 for some hours. So, that it gives a very stable coating on the surface. So, that we can say the heat cured coating will last longer compared to the air cured coating, and of course, the air cured coating will be better than no curing surface. If you apply a coating on the surface and immediately use, it will not be that much stable, but if it is cured properly, then it will be having more and more stability. Now, we can classify solid lubricants based on their molecular structure. We say that easiest one is a polymer, they have a lesser chemical reactivity, but they have a low melting temperature. Then we have some metals in solid form. We are using the word solid, metal solid, because we know very well the metals also can be used as a liquid lubricant, as a liquid lubricant when the melting or the operating temperature is very high and the metal really flows. So, we don't want to mix these together. We say that in this case we are particularly using metal in solid form. And finally, comes to the cermet. Cermets are generally a mixture of ceramics and metals. Metals are used as the binders for a ceramic material, and we know the ceramic materials have a very high temperature, high melting temperature, and this kind of composition can be used for the high temperature applications. We have found number of applications, or I think we have seen the number of application of the solid lubricant. It may be a number of bushes. You see the washing machine, you see the any juicer mixture, we find this kind of bushings, polymer bushings, they act as a solid lubricant in them. They do the dual purpose, they support the shaft, rotating shaft, and they support, they also use as a lubricant there, both the sources together. We have seen also as a separator in the rolling element bearings. Rolling element bearings, we have inner ring and outer ring, and then the separator along with rolling elements. If we do not use a separator, what will happen? All the rolling element can club together at one place, and will show high load carrying capacity at the 180 degree, and remaining 180 degree it will not show any load carrying capacity. So, we required proper control load carrying capacity and control friction. That is why we use cages or separator. That is why we are writing here this, it can be used, or this kind of solid lubricant can be used with the cages. It can be polymer based complete one, or can be some sort of bronze based, but with a solid lubricant applied, or solid lubricant coating applied on that. Heard about electrical brushes, generally they are carbon based or graphite based or carbon graphite mixture. They use as one block lubricant. I am just showing one example which we have done in our laboratory is a graphite seal ring. Now, what is the disadvantage of this kind of rings? Advantage is the number, the huge number. So, this seal is used to stop the steam leakage. Steam itself is a high temperature fluid. We are talking about the saturated steam is 120 degree, 130 degree, 150 degree centigrade. So, we required seal which also gets self lubricated. When we talk about the self lubricated, naturally the question comes whether they have a solid lubricant along with other composition. Maybe in this case it is a mix with antimony, carbon graphite mixed with antimony. Carbon graphite being used as a solid lubricant, where the antimony is being used as to increase the conductivity, to increase the impact resistance. But problem with this kind of seal rings or this kind of a block solid lubricant is that if there is a wear, you can see the wear marks on that. If there is a wear, then their intended function will not be fulfilled. Then they will start losing the intended function, and that will turn out to be a failure. So, we need to use some other mechanism, so that there is a self healing property comes in this kind of block lubricant also. This is not a coated, it is a complete one block, and one way is that you push with a spring. So, wherever there is a wear and getting pushed with a helical spring, again regain its position. Even though wear out, thickness is decreasing, but it is coming back to the same position. This is what one diagram shows, a seal ring. This is what we call a rotary joint complete unit. You can say the steam goes in and try to push this kind of stainless steel shafts. There is one stationary joint, another rotating joint, and these are the seal rings. This is a radial kind of a seal ring, and this is another seal ring which I showed in a previous slide. This is a seal ring which we are talking about, the wear out happens. And if there is a leakage of steam, then there is a loss of the fluid or required fluid that we require to stop it. Now, if there is a seal ring is getting worn out, or there is a wear of the seal ring, there is a spring over here which pushes the shaft against that. If the thickness of the seal ring is reduced, because we have already used a pre-compressed spring, it will adjust position of the seal ring. So, that means if we are using a solid lubricant as a one block, there should be some arrangement which gives a self healing property to the solid lubricant. Otherwise, it will be a failure. Otherwise, if we do not use this kind of a spring and use a seal ring, maybe say after a couple of hours, the seal ring will wear out, and then intended function will not be fulfilled, and leakage will start. So, within a couple of hours, we need to remove the seal ring and we need to replace with a new one, which will be very tedious. Opening and closing this kind of assembly itself take a number of hours. So, if operating life of the seal ring is only few hours, then it does not have any meaning, or we should not be utilizing this kind of seal ring. That is why we use this kind of adjustment device, which gives overall favorable results to us. Another mechanism is that use solid lubricant as a thin film coating on the surface. Now, when we say thin film coating, it has advantages. First thing is that it will not wear out very easily. It has been observed with a decrease in a thickness, their bonding strength increases significantly, or it will not be shared out very easily, can sustain much higher loads, can sustain a high fatigue load also with a thin film. So, depends on our applications, we can use this kind of coating, but only problem in this is that if there is a wear out, then intended function will be lost and will be, we need to be very accurate, or we need to be able to estimate properly when the wear will occur, and before that we should be ready to replace this kind of component. So, there is a one mechanism to use this kind of a coating. Of course, we can use a carrier fluid when we are relying on this kind of a coating. We can use a carrier fluid on that along with the solid lubricant. Now, one of the major group of the solid lubricant is a polymers. We say that the polymers are suitable to bear the light loads. If you apply load with a high magnitude load, then they have a coefficient of friction, but we know the coefficient of friction into normal load will give the friction, and that if the friction force is very high, rate of heat generation will be high. Rate of heat generation is high and they have poor dissipation. Heat dissipation, their thermal conductivity is very low, then they will not be able to dissipate the heat. There will be heat accumulation, which will increase the temperature of these components, and if the temperature increases, then there is a possibility of plastic flow of this kind of polymers, which will lose its intended function, or which will cause the loss of the intended function. That is why we say polymers should be used for the light load applications only, and sometimes we use the polymers as the binding agents, right. So, PTFE is one of the well known concept. It has been utilized in a number of utensils by DuCom of the DuPont company, which is one of the new well known company for the PTFE, DuPont, which gave the name as a Teflon. So, that PTFE they do not use the word that PTFE, they use a Teflon coating, and I remember we have done the Teflon coating on the cars also. So, give a nice appearance. We know that the extra environment will not impose much load on the surface, and it has a shiny surface, glossy surface. So, that kind of coatings are very good. But major thing is they have a poor adhesion to the metals. That is why they cannot be easily applied. You need to rub it hard or apply more mechanical force to transfer polymers or PTFE from the block to the surface where we want to coat it. They show generally low coefficient of friction, that is because of they have spherical molecules, and spherical molecule structure is very advantageous, because they have easy gliding on the surface. That is why they have a low shear interface shear strength, they make interface with a low shear strength. However, they have a high wear rate. Their specific wear rate is 10⁻⁻⁴, and units are also mentioned here as mm³ per minute. When we want to reduce the wear rate, often we choose a nylon. Nylon is one of the most commonly used component in most of the toys, where the nylon bushes are used, or wherever requires slightly higher hardness, slightly higher life compared to this kind of wear rate. Obviously, the lesser wear rate is required, then we can use a nylon. Also easily available in an open market. However, the only disadvantage of the nylon in place of the PTFE is a high coefficient of friction. The coefficient of friction is 0.25. That means we lose almost 2.5 times energy compared to the PTFE. Again, we are using the word, they need to be utilized only for the suitable for the light load applications. Their specific wear rate is lower by 10 to 100 times compared to PTFE. However, PTFE has a major advantage of the coefficient of friction, and we do not want to lose it. That is why many times we use a synthetic polymers. PTFE is mixed with some other polymers to retain the low coefficient of friction and high life of the low wear rate. So, both low wear rate and low coefficient of friction by synthesizing, by hybridizing with other polymers or other components. That is why we are saying that polymers, if it is a mixed or is a PTFE is a mixed with a glass, carbon or glass fibers, they have they increase their strength. When they increase the strength, the wear rate goes down. And it has been observed the wear rate turns out to be only 10⁻⁷, a specific wear rate is 10⁻⁷ compared to 10⁻⁴, almost 1000 times increase in life when we are using synthetic polymers. This is mentioned over here. If we do not want to go ahead with low strength of the polymers, we should use some sort of metal base. When polymers or with PTFE or Teflon, they are applied on as a thin layer on the metal surface, their strength goes phenomenally high. Their strength is almost equal to the metals. If they are very thin, they applied a very thin coating, the few micron coating on the surface, they show very low coefficient of friction, they show very high strength. We get a win-win situation. And this has been already shown in a previous slide, this figure. If we apply polymers, if I assume this is a metal and this is a polymer, they give very high life because their strength is increased. They can sustain more load. Whatever load is applied, they will deform to some extent, and deformation possibilities are lesser because this is not a complete bulk polymers. In the bulk polymer, the deformation will be enormous, but the thin coating of the polymers and the back is the support provides reduces the deflection, and then this kind of coating can survive, right. However, still there is one problem, even though the strength is increasing, but thermal conductivity is not increasing. That is why if we use a metal which has a very high thermal conductivity, in that situation we will get a win-win situation, or we will get both favorable cases, high thermal conductivity overall of this the layered structure, high strength and low friction. That is a win-win situation. Now, see the structure of PTFE, or what is called the polytetrafluoroethylene. You can see they are all balls. We know the ball will roll easily, right. That is why they show very low interface strength. If the free surface has this kind of a structure, and they under compression they deform. That is why if the coefficient of friction will increase with a increase in load, that means they do not follow Coulomb's law completely, but to a light load application, yes, they follow. As this slide clearly indicates that this name was given by DuPont at Teflon. They do not use the word PTFE, they use a Teflon. That is a name given, the trade name and given by this company. However, in this slide also we are trying to show what are the strength of PTFE and what are the weaknesses of the PTFE, right. Say PTFE does not react easily with a number of substances. So, they have more chemical stability. They remain in a same position, same structure for a longer time without reacting, without changing their structure. They change the structure under the load condition, under the high temperature, but not in a chemical environment, right. And it has been mentioned that they have more inertness. This is basically the ethylene and all the hydrogen bonds were replaced by the fluorine. So, that gives a very high chemical affinity, chemical stability to the compounds. They have a low surface energy, that is why they show low coefficient of friction. They have a low shear strength at the interface, and of course, there is a low velocity is permitted, low wear rate is also there. One of the interesting, another major advantage of Teflon or PTFE is a non-toxic behavior. Can be mixed with the food and it will not harm to the body. That is the reason why the most of the utensils are coated with a Teflon. They do not spoil the food. they go show the low coefficient of friction. So, we can cook food with much lesser oil compared to what oil is required without Teflon coating, and they can be used in a number of pharmaceutical pharmaceutical applications. This is a major advantage of a PTFE. However, there are some weaknesses. You say it is a soft, so wear rate will be high, and to reduce the wear rate we need to do something with a PTFE. They have a poor creep resistance. There is another reason why we use a PTFE with a metal base, or we use with some support. They are poor, they have poor creep resistance if they are used in the bulk, but a few molecular thick layer or even a 0.5 mm thick layer will not show that bad creep resistance or creep behavior. Thermal conductivity is low, that is why again we required hybridization with polymers, other fibers or metals which will increase thermal conductivity. Now, this is a final bad thing about PTFE. You say the vacuum is detrimental. They start vaporizing, they start degassing the component. So, that is why they are not effective at particularly when they are used in vacuum situations. That is why we cannot use this kind of solid lubricant in extreme cases. Now, as I mentioned in previous slide, most of the disadvantages of PTFE. See, advantages are very favorable, but there are disadvantages and we need to do something after learning what PTFE can do. Most of the disadvantages of PTFE can be overcome by using fillers to increase the strength, by impregnating with the metals to increase the thermal conductivity, and we can say that by synthesizing these polymers, right. And it has been also mentioned over here that by with a suitable rigid backing, PTFE can withstand or reduce the wear rate, can withstand high temperature load or high load, that is stress level can be even 100 megapascal, but maintaining still a low coefficient of friction. When the coefficient of friction is consistent, what we are talking about the static coefficient of friction and kinetic coefficient of friction, they are almost the same when we are using the PTFE. That is a major advantage of PTFE. If I talk about the liquid lubricants, without sliding, without relative velocity, coefficient of friction will be high. That means the static coefficient of friction may be as high as 0.25. Under dynamic condition, when the sliding is started and the hydrodynamic film is completely made, coefficient of friction reduces to 0.001. A huge difference between 0.25 and 0.001, that I am sure is going to give a stick slip phenomena, unless we support hydrodynamic action with some other action. Well, in case of the PTFE, they show the same static coefficient of friction and almost the same kinetic coefficient of friction, there is no variation. That is why we say that it is almost freedom from stick slip phenomena. That is why PTFE can be utilized. Of course, as I say, PTFE alone cannot be utilized, it need to be mixed with some fillers, need some support for the, so that thermal conductivity is increased and sustainability or to resist the compressive force increases. Now, finally, the coming as when two polymers in sliding contact should not be utilized. If I am using one polymer, I should use other metal. Reason being, when we are using polymers with a interface of the metal or in the ceramic, polymer will get deposited to other surface itself, will make a thin layer. So, if I use a two bulk polymers, it does not have much use. I use a one metal and one bulk polymer, then it will have a better results. That is why this note comes is that two polymers in sliding contact will normally operate at significantly lesser speed than polymer against the metal surface. One is a metal has a high thermal conductivity and high sliding speed means high friction heat. High heat means required high dissipation, which in case of the metal has, but otherwise it does not have. So, we say this kind of polymers will be recommended when we have low speed condition, when the sliding speed is very low, then we can use the two polymers, but they turn out to be cheaper, they may be non toxic and can be utilized easily. But sliding speed is higher than we required by polymers, maybe so the few meter per second. In that case, one polymer should be utilized with other metal surface, but if sliding speed is almost negligible, then we can utilize our two polymers together. We will continue with the classification of a solid lubricant in our next lecture. Thanks for your attention. Thank you.